Okay, in lesson 13, we're going to be looking at the angle sum of a triangle, looking a little more in depth at it. And to review what we've talked about in previous years, you know that the three angles that make up a triangle all add up to 180 degrees. So we'll put a little note right here. Angles inside a triangle add to 180 degrees. So what this first example right there on the first page is showing you is that in this first triangle we have angles 1, 2, and 3. We know that those all have to add up to 180 degrees. Angles 4, 5, and 6, it doesn't matter what they are. Those, when you add all three of them together, will also equal 180 degrees. And the same thing for angles 7, 8, and 9. When you add those together, they equal 180 degrees. So what this is showing you right here is that these three angles equal 180 degrees. These three angles equal 180 degrees, and these three angles equal 180 degrees. So therefore, the sum of all of them are going to be equal. Now, it also has a note there underneath the sum of the angles. It says that note that the sum of angles 7 and 9, so over here, if you add 7 plus 9 together, that has to equal 90 degrees because we knew right here that angle 8 had to be 90 degrees because of that little box. And 180 minus the 90 is 90, so these together would have to equal 90 degrees. Now, in this lesson, we are taking it one step further because we are actually going to prove why the angles inside a triangle add up to 180. So, we're going to need three different facts here to prove that that is going to be true. So the first one, and you can write these down in that empty space down there, a straight angle or straight line is 180 degrees. Again, that should be a review. The second thing, and you can abbreviate these, corresponding angles of parallel lines are equal. And we just learned that in lesson 12. If we have a set of parallel lines, and I'll just draw a little figure over here. If these lines are parallel, corresponding angles, that means on the same side of the transversal and in the same relative position. So these two that I marked in red, those are equal as long as these lines are parallel. Okay, and then the third thing that we need to know is that alternate interior angles of parallel lines are also equal. Okay, so you can take a minute in this diagram and figure out where the alternate interior angles are. They're going to be inside the parallel lines and on opposite sides of the transversal. So right here that I'm marking in blue, that's one set of alternate interior. This also that I'm going to mark in black, the black and the red one, excuse me, would also be alternate interior. And those are equal to each other as long as, again, these lines are parallel. So these three statements are ones that we have already talked about in previous lessons. And we're going to use those to prove why the three angles inside of a triangle add up to 180. Okay, so moving over to the next page, we have Exploratory Challenge One. And that says, let triangle ABC be given. On the ray from B to C, so right here, take a point D so that C is between B and D. So they've plotted that for you. C is between B and D. Through point C, draw a line parallel to AB as shown. So this is your line that's parallel to AB. Extend the parallel lines AB and CE. Says, so if we extend these, and you can draw this in on your paper if you'd like. So we're going to extend these in either direction. Just know that they would keep going on and on forever. Okay, then it says line AC right here is the transversal that intersects the parallel line. So I'm going to go ahead and extend that also so you can see that it clearly intersects those two parallel lines. So using that diagram, we're going to answer the questions down below. So part A says to name the three interior angles of the triangle. Now, you're probably thinking that's A, B, and C, but we're going to, and you're right, but we're going to be a little more specific with how we name them. Now, when you name angles, you always have your angle symbol, and you're using three letters that make up the angle. So if I'm looking at this angle right here, angle, what we call angle B, I am going to name it with all three of these letters that make up that angle. But since it's angle B, the B has to be in the middle. So I'm going to call this angle A, B, C. So that's one. The second one would be this one right here. I just got to make sure my C is in the middle. So A, C, B. Or if you wanted to call that BCA, it would be the exact same thing. And then finally we have the angle up here, angle A. As long as A is in the middle, it'll be fine. So I will name this angle BAC. So those are the three interior angles that make up that triangle. Now part B says to name the straight angle. A straight angle is just a straight line. So they're talking about this one right here. And we will just name that right in order, angle BCD. So our entire goal for this lesson is to show that these three angles, these interior angles of the triangle, are equal to the angle that makes up the straight angle or the straight line. So we already know that this is equal to 180 degrees. So if we can show that these three angles on the inside of the triangle are the same as this straight angle, then we will have proven that these will add up to 180 degrees. So let's move on to part C. Part C says what kinds of angles are angles ABC, so ABC, that's this one right here, and ECD, that's this one right there. And then what does that mean about their measure? So if you look, here were the parallel lines. We can extend those. Okay, so they're on the same side of the parallel line, of each parallel line, in the same relative position. So those are corresponding angles. And then what does that mean about their measure? Well, we will just say corresponding angles, and you can abbreviate that. Corresponding angles of parallel lines are equal in measure. The whole key to this right here is of parallel lines. If the lines aren't parallel, they're not going to be equal. So the lines have to be parallel. Now, part D says what kind of angles are angle BAC so that's this one right here, and ECA, which is right here. If I use it, I'm going to use a different color so it's easier to see. Okay, the green ones. Okay, so if you notice, here's your transversal right through here. Okay, they are on opposite sides of that transversal, so alternate sides, but they're on the inside of the parallel lines. So that would be alternate interior angles. And then what does that mean about their measure? I'll abbreviate this one. Alternate interior angles of parallel lines, again they have to be parallel, are equal in measure. Okay, so first we looked at, for part C, we looked at these two angles in blue right here. They were equal in measure because they were corresponding angles. Then we looked at the angles in green, and they were also congruent because they were alternate interior angles. So, moving on down to part E, it says we know that angle BCD, so that's the straight angle, equals BCA, which is that angle, plus ECA, which is that one, plus ECD. So all they did was they took that straight angle and they broke it up into the three separate angles. And we know that if we add all three of these together, it has to equal 180 degrees. So it says use substitution to show that the three interior angles have a sum of 180 degrees. Okay, so here's what I'm working with. We have BCA plus ECA plus ECD, and that equals 180. So from part C above, it says angle ABC and ECD are congruent. So I'm going to take and I'm going to replace this one right here with angle ABC. And then on part D, it mentioned that BAC and ECA were the same. So I'm going to replace this one with angle BAC. And if you add all those together, it shows that it equals 180. And these right here are the three interior angles of the triangle. So there's our proof for how the three inside a triangle equal 180. Okay, so over on the last page, we have this diagram here, and we will be using it for the problems below. Part A, name a triangle in the figure. There's only one triangle right here, BCF. Part B, name a straight angle that would be useful in proving that they add up to 180. And that would be this one right here, angle GFE. Then part C wants us to prove it. Okay, so I know that the angle GFE is comprised of GFB and BFC and EFC. And I know that those all equal 180 degrees because it's a straight line. Now, the corresponding angles, I know, okay, right here I'm going to replace EFC with BCF, and I'm going to replace GFB with CBF, and then BFC is still part of it. So there, that proves those are the three interior angles that make up that triangle.